Hello everyone, so in this video, let's talk about a middleware problem from LeetCode. The problem name is Zigzag conversion. As you can see, you are given a string. You're given different strings depending upon the input, and you have to convert this in a zigzag pattern. First of all, when I first saw this problem, I was not actually able to understand what this zigzag pattern actually means. But on closely looking upon, you are also given the number of rows. Okay, so you are given two things as an input: the pattern that you want to make into a zigzag pattern and the number of rows. Such that you have to print it in this manner, such as you can see, if I take this above, what you can see here is if this is the string, okay, what you can see is that it goes like this in this manner. So this is the zigzag pattern. So it goes in this manner: down, diagonally, down, diagonally, down, diagonally, down. That is how the pattern look like. You have to print this particular string, whatever you have, in this particular format. Given that when you go down, the number of rows should be equal to the given num rows, and then you go diagonally up like this in the manner, and then you go down. Okay, so that's the overall problem that you have to solve. Now it's not pretty much difficult, it's just implementation type of problem in which you have to first go down, and then when you have reached the last row, then you have to go in the diagonal manner until you again reach the first, you can say, row, in which when you go in this diagonal manner, if you go in this diagonal manner, what you can see is that you are going in the right direction and the up direction. Right direction means that your J, if you're assuming that this can be some sort of a 2D matrix like this, the number of rows is given to you, the number of columns you can also calculate, but because the length is not that much, you can make the number of columns in this equal to the length of this particular string as well, even though it will be smaller, but just for the sake of this particular problem, you can also optimize it. But yeah, for my use case, I've just created the number of columns equal to the length of this string, because obviously it will be smaller only. What we have done is that this is the number of columns in length of the string, and this is the number of rows that is given to you. You first go down, and you have to keep track of what, like, you can say which cell you are on. So you can make I comma j, you can start from 0 comma 0. Then you first go down. That when you go down, it means that I increases, so I plus plus. When you go to the last call row, then you go in this manner, which means that now the row decreases, so will be I minus minus, but j increases, so j plus plus, until you again reach the very first row, and then you repeat the same thing until you have exhausted all the characters of this particular string. That's pretty much same logic that I've done, nothing much complicated. So I'll move down to the code part now, but if you still have any doubts, you can mention in the comment box. So what I've done here is, as you can see, we have n, the number of elements in this string, the column that is also given to you. So columns I have defined as this, and row is given to this. So I've made a matrix in which I have inserted all these values as a dollar, but now we have to make it some another string, so we have initialized it with dollar. Whatever you can want, as like whatever you want, you can make it empty character as well, whatever you want. Now we have to have three variables used to define, two I and j defined on what cell I am on which I want to fill in the new matrix, and k defines what is the character I am on the string, because I have to take every character on the one and insert it inside this pattern. Okay, so and we have to keep on doing it until we have exhaust all the characters of the string. So we have taken this. Now we have done a while loop, and this while loop is that it should keep on going until my k, the number of characters I have still present to be filled inside the matrix. So k should be less than n, the length of the string, and we should be inbound, which means that I should be less than rows and j should be number of columns. So these are the three conditions that should be met. We should not go out of bound, or like the number of characters we should still have. So if we still have, then what we can do is that we can keep on adding our kth character at the I comma j cell, and we can keep on incrementing our I, which means that we should keep on going in the downward direction. We can keep on doing this while loop, and we can go in a downward direction up till what you can see is that if I somehow reach the last row, you can keep on doing this. This if condition will not hit at any time if you are going down this particular number of rows. But if I reach the last row, so which means that if I leave the, like, go on out of bound, which means that now let's say I filled P A Y, now I have gone out of bound. So which means that now I have to fill this character. This character is 2 steps ahead because I am out of bound. So one step is this row and the step is this row. So I have to go 2 steps back in the row and 1 step ahead in the column. Okay, that is what we have done to reach this state. And now from this state, I have to go in the diagonal direction. So if this should be inbound, so we'll go in diagonal directions, which means that I subtract j plus plus, k move plus plus. Let's just keep on doing this. And if we keep on doing this such that we should be inbound, and if we somehow go out of bound, let's say if I become less than 0, we should make our I equal to 0. When can this happen? Let's take an example. Let's say if only have one row. If we only have one row, we fill the first character here, let's say A, then we go out of bound because we keep on going down, then we go out of bound. So when we go out of bound, what we are trying to do here is that we have now moved 2 steps ahead. We have like 1 step ahead and 2 steps ahead because now we are thinking that we should go in the diagonal direction, so we should come here. But that is out of bound. So if we go out of bound somehow, because due to this condition that I have added here, we should somehow make my I equal to 0. It's a very edge condition. You can only get it by some examples in which, like, this is a very edge condition if I only have one row. But if I have only one row, then this condition will cause a problem. And in that condition, if I somehow go less than 0, we should make it 0, because which means that we should not go out of bound. We should only fill it in this particular. Okay, that's a complete logic on the code part for this particular problem. If you still have it out, you can mention in the comment box. And in the end, what we have done is that we have printed out the complete string. Yeah, so we have this string. So we have now populated all these characters inside this matrix like this. So now we have to print out this particular string in row wise manner. So let's say the string output will be P, A, H, N, A, P, and so on. So we have the matrix inside. So we can just now go in the row wise manner and the column wise manner. The same just iterate over the string. And if the characters that we have filled is not dollar, because we have initialized and started with dollar, if it is not dollar, which means that we have to get the characters that we have filled, we'll just do a row wise traversal over the matrix and just store the characters inside the string and just print out. Okay, nothing much complicated here itself. It's just a little bit ad hoc and implementation type problem. Nothing much difficult here as well. So if you still haven't out, you can mention in the comment box of this particular video. I will see you next one. Coding, and bye.